Hello again, this is the Pencrest High School AP Physics 1 video series. This is video 9D, voltage and current. Now, most people are reasonably familiar with the term voltage and they tend to associate it with batteries. It's not a bad association, but we're going to need some more details here. Voltage is defined as the difference in electrical potential energy per unit charge between two different locations. If we wanted to move a charged particle from one place to another, typically we would have to do work in order to do so. The work done per unit charge between the 2 points could be called electrical potential difference or the voltage. We can also describe voltage as what's called an electromotive force or EMF in the circuit. It's what makes the electrons want to move through the circuit. In a sense, voltage pushes electrons from one end of the circuit and pulls them from the other. We would describe the potential difference or the voltage across the plus and minus terminals on a battery. We're familiar with, for example, a AA battery. The end with the little button on it is typically the positive terminal and the other end is the negative. Most AA or AAA batteries have a voltage of 1.5 volts between their terminals. This one here we're familiar with. It's a standard 9-volt battery. It's called that because the potential difference between the positive and the minus negative terminals is 9 volts. Here's a car battery, typically has a voltage of 12.6 volts. Here's a lantern battery, usually has 6 volts, and so on. Now the symbol for voltage is a capital V. The bad news is that this is also the symbol for the units used to measure voltage, which is also capital V. It can conceivably lead to some confusion, but usually you'll be able to differentiate them. Again, a volt is defined as energy per unit charge, so that 1 volt of potential difference equals 1 joule per coulomb. Now, moving on to current. Current describes how much charge is moving through the circuit in a given unit of time. The symbol for current is capital I. It's not to be confused with rotational inertia. Fortunately, they're not going to usually show up in the same problem. Current is measured in amperes or amps. The symbol is capital A. I have seen it labeled with a lowercase a, but for our purposes use capital A. An ampere is defined as a coulomb per second. The ampere is named after somebody, but oddly it's not capitalized like newtons or coulombs. I'm not sure why. But we describe current in amperes. Again, 1 amp is equal to 1 coulomb per second. Now, current is made up of moving electrons. It's called electron current that move from the negative terminal of the battery to the positive terminal. For some reason, conventional current is said to be made up of positive charges that move from the positive terminal to the negative terminal. Doesn't really matter. We can sort of stick with conventional current for our purposes. It really doesn't matter as far as the quantitative calculations matter when we start to get into calculating voltages and currents. It doesn't really matter which way they go for our purposes. The symbol at the bottom here, this is the schematic symbol for a battery. We will get into schematic diagrams and resistors and batteries and whatnot coming up soon. So, okay, that's it for voltage and current. Next up is parallel and series arrangements of resistors and DC circuit analysis. Until then, enjoy, and I'll see you again soon.